several types of volcanic eruptions, during which lava, tephra, and assorted gases are expelled from a volcanic vent or fissure, have been distinguished by volcanologists. These are often named after famous volcanoes where that type of behavior has been observed. Some volcanoes may exhibit only one characteristic type of eruption during a period of activity, while others may display an entire sequence of types all in one eruptive series. There are three different types of eruptions. The most well observed are magmatic eruptions, which involve the decompression of gas within magma that propels it forward. Phreatomagmatic eruptions are another type of volcanic eruption, driven by the compression of gas within magma, the direct opposite of the process powering magmatic activity. The third eruptive type is the phreatic eruption, which is driven by the superheating of steam via contact with magma. These eruptive types often exhibit no magmatic release, instead causing the granulation of existing rock. Within these wide-defining eruptive types are several subtypes. The weakest are Hawaiian and submarine, then Strombolian, followed by Vulcanian and Circean. The stronger eruptive types are Pelian eruptions, followed by Plinian eruptions. The strongest eruptions are called ultraplinian. Subglacial and phreatic eruptions are defined by their eruptive mechanism and vary in strength. An important measure of eruptive strength is volcanic explosivity index, an order of magnitude scale ranging from 0 to 8 that often correlates to eruptive types. Volcanic eruptions arise through three main mechanisms. There are two types of eruptions in terms of activity: explosive eruptions and effusive eruptions. Explosive eruptions are characterized by gas-driven explosions that propels magma and tephra. Effusive eruptions, meanwhile, are characterized by the outpouring of lava without significant explosive eruption. Volcanic eruptions vary widely in strength. On the one extreme there are effusive Hawaiian eruptions, which are characterized by lava fountains and fluid lava flows, which are typically not very dangerous. On the other extreme, Plinian eruptions are large, violent, and highly dangerous explosive events. Volcanoes are not bound to one eruptive style, and frequently display many different types, both passive and explosive, even in the span of a single eruptive cycle. Volcanoes do not always erupt vertically from a single crater near their peak. Either, some volcanoes exhibit lateral and fissure eruptions. Notably, many Hawaiian eruptions start from rift zones, and some of the strongest Circean eruptions develop along fracture zones. Scientists believed that pulses of magma mixed together in the chamber before climbing upward, a process estimated to take several thousands of years. However, Columbia University volcanologists found that the eruption of Costa Rica's Irazu volcano in 1963 was likely triggered by magma that took a non-stop route from the mantle over just a few months. The Volcanic Explosivity Index is a scale from 0 to 8 for measuring the strength of eruptions. It is used by the Smithsonian Institution's Global Volcanism Program in assessing the impact of historic and prehistoric lava flows. It operates in a way similar to the Richter scale for earthquakes, in that each interval in value represents a tenfold increasing in magnitude. The vast majority of volcanic eruptions are of VEIs between 0 and 2. Volcanic eruptions by VEI index. Magmatic eruptions produce juvenile clasts during explosive decompression from gas release. They range in intensity from the relatively small lava fountains on Hawaii to catastrophic ultraplinian eruption columns more than 30 kilometers high, bigger than the eruption of Mount Vesuvius in 79 that buried Pompeii. Hawaiian eruptions are a type of volcanic eruption named after the Hawaiian volcanoes with which this eruptive type is hallmark. Hawaiian eruptions are the calmest types of volcanic events, characterized by the effusive eruption of very fluid basalt-type lavas with low gaseous content. The volume of ejected material from Hawaiian eruptions is less than half of that found in other eruptive types. Steady production of small amounts of lava builds up the large, broad form of a shield volcano. Eruptions are not centralized at the main summit as with other volcanic types, and often occur at vents around the summit and from fissure vents radiating out of the center. Hawaiian eruptions often begin as a line of vent eruptions along a fissure vent, a so-called curtain of fire. These die down as the lava begins to concentrate at a few of the vents. Central vent eruptions, meanwhile, often take the form of large lava fountains, which can reach heights of hundreds of meters or more. The particles from lava fountains usually cool in the air before hitting the ground, resulting in the accumulation of cindery scoria fragments. However, when the air is especially thick with clasts, they see